Hello folks, so in this video I wanted to show you how I'm solving some problems on LeetCode. So I have some 2-3 problems in mind. Let me show you. So this is a problem that I saw a few days back. This was one of the daily problems, daily question, right? So one moment. Okay, so I think this was the daily question for 16th February 2025. So this is the question, right? So it says construct the lexicographically largest valid sequence. So we have to construct a sequence, valid sequence. So given an integer n, find a sequence with the elements in the range with elements. So it has elements, it's a sequence, it has multiple elements. So the elements are in the range of 1 to n, right, given an integer n that satisfies all of the following conditions, like all of the following, which is the integer 1 occurs once in the sequence. Each integer between 2 and n, I believe it's inclusive of 2 and n, occurs twice in the sequence. So for every integer I between 2 and n, the distance between the two occurrences of I is exactly I. So for example, here they say the distance between the two numbers of the sequence on the sequence, a of I and a of j. So let's say both the numbers are the same. Then the distance between the two numbers is the absolute difference of their indices, j minus I. So for example, they'll show you an example. One moment. I've read this question some 1 week back itself, but I didn't write the code for it. I just solved on my notebook. I'll show you how I've done it. I had some doubts on how do I go about solving it programmatically, but now I think I have an idea, so I'm going to solve it. So it says return the lexicographically largest sequence. It is guaranteed that under the given constraints there is always a solution. So a sequence A is lexicographically larger than a sequence B of the same length if in the first position where A and B differ, sequence A has a number greater than the corresponding number in B. For example, 0190 is lexicographically larger than 0156. Because the first position they differ is at the third number, which is here 9 and it's 5 here, and 0190 9 is greater, so 0190 is greater, lexicographically larger than 0156. So they're giving examples. If n equal to 3, then basically you have 1 2 3, and 1 occurs once, and then 2 occurs twice, 3 also occurs twice. All the numbers after 2 from 2 till n, including 2 and n, are occurring twice. And the distance, if you see, 1 occurs only once. For other numbers, that is 2 and 3, the distance. So for 2 it is, if you can see here, the indices are 0 1 2 3 4. So 2 and 4, 4 minus 2 is 2, right? And then for this it's 0 1 2 3, 0 and 3, 0 minus 3 or 3 minus 0, absolute is 3. So for this absolute is 2, great, or this absolute is 3, so it's a good solution. Explanation: 2 3 2 1 3, which is 0 1 2, so 0 2 is fine, and 1 4 1 minus 4 or 4 minus 1, it's 3. So all this is also a valid solution, but 3 1 2 3 2 is the lexicographically largest valid sequence, right? So both are right, but then the largest, they want the largest valid sequence. So yeah, it should not just be a valid sequence. So for input 5, it's this, right? The constraints are the value of n is between 1 and 20. So I don't remember seeing this question, so I'll just say no. And topics is array, of course. Companies, they don't say anyways, because I don't have it. And A heuristic algorithm may work. I don't know what is heuristic algorithm, so great. I'll probably go ahead and solve this. The thing is, how I tried to solve this is, I first of all, I'll show you my notebook. I think this was it, yeah. I started here. So, one moment. Okay. So basically the idea was, first of all, to understand the size of the sequence and all, because it's going to be fixed. Given they're saying the integer 1 occurs only once, and then all the other integers occurs twice. So you can see over here number of occurrence for this number 1, for this digit it's once, for 2 to n it's twice. So it's basically, the length will be basically 1 plus, this is how many numbers, including 2 and n, it's basically n minus 2 plus 1, right? Basically n minus 1, basically 1 to n including 1 and n is n. Without 1, this digit, it's basically minus 1, so n minus 1. So 2 occurrences, so 2 into n minus 1, so 1 plus 2 into n minus 1 was the size, right? 1 plus 2 into n minus 1. If n is 1, 1 minus 1 0, so it's 1, right? And if n is 2, the size is 2 minus 1 is 1, 1 plus 2 is 3, and then n is 3, 3 minus 1 2, 2 2s are 4, 4 plus 1 5, and so on. If n is 20, 20 minus 1 is 19, 19 2s are 38, 38 plus 1 39. So the size is fixed, right? And once you have an n, and that is the biggest n that you have, right? And the maximum size of the numbers will just be 20. One of each element, it's just 20, right? So it can be 1 to anything between 1 and 20, inclusive of 1 and 20. So you can use an array or anything where each element has a very small integer, small int or integer of 8 bits or 16 bits, because that is enough. You don't need 64 bits over here. So now for lexicographically largest sequence, or like let's say there are two sequences A and B, right? Now let's say A is of size n and B is of size n. Only then you can compare the two, or else you can't even compare. So now A1, A2, A3, A4, these are the elements, An, B1, B2, B3. If AI is equal to Bi, for I is equal to 1 to x, somewhere, right? X can be somewhere in between, right? X can be somewhere in between. So 1 to x, where x belongs to somewhere between 1 to n, right? But a of x plus 1 is not equal to b of x plus 1. That is the first differing point, the x plus 1 point. Then a of x plus, then if a of x plus 1 is greater than b of x plus 1, then a is greater than b. Else if b of x plus 1 is greater than a of x plus 1, then b is greater than a, right? If both are equal, this wouldn't be the case. So both won't be equal. It will either be less than or greater than. So now let's look at how we can create, how we can come to the answer of, like, say n is equal to 3. How do you come up with the answer, right? So I was actually thinking maybe you can use dynamic programming, and if you solve for n equal to 3, you can use that solution to solve for n equal to 4 by just adding 4 twice here and there, right? But we'll come to that. So what I did was, n equal to 1 is just 1, n equal to 2, it's basically only 3 possibilities are there, because you have 2 2s and 1 1, right? So basically that's only 3. Size is 3, as you can see here, n equal to 3. So if the size is 3 and 2 2s and 1 1, then you can basically put the 1 in the left, in the center, or in the right. So if you put it in the left, the distance between the two 2s is actually 1, because if the indexing is 0 1, 2 2 minus 1, so it's 1, which is wrong. It shouldn't be 1. So then if you put it in the center, then it can be 2, so which is correct. Here again it will be wrong, so it'll be 1, so it'll be wrong. So this is the right answer. Now I thought with this as the right answer, 2 1 2, can we actually make the n equal to 3, right? So we have 2 1 2. Now the distance between the two 2's are correct. Can I actually add a 3? And if I don't add any 3 over here, then only the distance will remain the same. If I add a 3 here, the distance will increase off, right? So anyways, so I was just looking at, can I actually simply add 3's? For example, here, let's say I add a 3 on the left and right. 0 1 2 3 4. The distance between the 3's is actually 4, which is wrong. So this is wrong, right? So 3 2 1 2 3, for example, this one 3 3 is wrong, 2 2 is correct, right? Now if I have 2 1 2 and I can't add 3 over here, because then the distance between the 2's becomes more, right? I can't add a 3 here and here, or say something like 2 3 1 2 3. You can't do this also, because this is like 0 1 2 3 4, right? Now what happens is this is 4 minus 1 3, okay, but this is 3 minus 0 3, wrong. This is also wrong, because 0 1 2 3 4, the 2's are pretty wide, and the 3's are also pretty close, right? So how do you come up with an answer, right? So this is also wrong. Let's see if this is correct. You added 2 1 2, you added 3 in between, and then you added 3 in this side. For the 3's it's proper, 0 1 2 3, so it's proper, but for the 2's it's wrong. So how do you come up with an answer then? Then I realized, okay, I can't just go ahead with this idea. Let's see how we can come up with an answer, and then I'll show you what else I tried before. So for 3, let's say I know for 2 it's 2 1 2, n equal to 2, and n equal to 1, it's 1, right? 0 1 2, the distance between these two is basically proper, right? Now the thing is, can I actually make this better? And then I realized I can actually swap. The 1 doesn't have to occur here only. The distance between the 2's has to be like this. The 1 doesn't have to occur here only. Like, the 1 can occur anywhere. The distance between the 2's should be 2. So I thought maybe I can just keep the 2 like this, 2's, and swap the 1 over here, right? Remove the 1, put a 3 here. Now I can put a 3 on this side or this side. I can't put it here again. The distance will become a problem. So where do we put it is the question. Now let's say if I put it over, so the other thing is, how do you understand the gaps, right? For example, the gap between two 2's should be how much? They say it's I minus j, right? Or j minus I and j. It should be 2, right? So j minus I should be 2 in this case, right? So let's say 0 and 2. So it's 0, 1, 2. So the gap, you look at the gap is just 1. If it says 0 and 2, it can be 0 and 2. It can be 1 and 3. It can be 2 and 4. It can be 3 and 5 and so on. The gap is 1. So here for 2 is the gap is 1. In that one gap I'm adding 3. Now for 3 the gap is going to be I, j minus I. Gap is going to be 3, right? So now it can be say 0 and then 3 and then 1 and then 4. So if you can see 0, let's say if the indices are 0 and 3, then it's going to be 1, 2. There are 2 gaps, right, between these two. So now if I put a 3 over here, there will be only 1 gap between the 2 3s. That is wrong. I can't put a 3 over here also, it's wrong, right? Because the gap will just be 1. The distance between these two 3s will just be 1. We want it to be, not the distance, but the gap between the 2 is just 1. We want the distance to be 3 and the gap to be 2. Distance is inclusive of the whole thing, of the indices, but the gap is just between the 2 3s. How much gap is there, like how much numbers can come in between, right? So I was like, okay, so you can't do this. So you do 2 3 2. Can you put a 1 somewhere? If you put a 1 over here, it's a problem. If you put a 1 over here, it's a problem. Because you're increasing the gap between the 2s. There should only be 1 gap between the 2s, not more than that, right? So now what can I do? I can actually just do 2 3 2. I can put a 1 on this side and increase the distance, probably put a 1 and 3 here, or I can put a 3 and 1 in the front and then say this. I can put these two, right? I can do this. This causes the distance between these two and the gap as 2 and the distance is 3. This is proper. This is also proper. This is also proper. So if you can see, it's 0 1 2 3 4. 4 and 1 3. 2 and 0 this one 0 1 2 3 4. Now with that in place, how do we actually make this into an algorithm, right? Looking at the space and whatnot. And the other thing is, there are two solutions now, but they want the largest lexicographically valid sequence, right? Which is bigger in these two? You see, when you compare these two sequences, it differs in the first position itself, and this has 3 and this has 2. This is the bigger one. So you want an answer like this, right? So if you think about it, let's say this solution was not even possible, then we will go for this, right? So I was thinking about a solution where you can actually arrive at this place by by actually trying out something different, right? For example, how does 4 work out over here? Let's see, right? So I got the answer for 3. It's 3 1 2 3 2. I believe that's the answer. We even saw it over here. Let me just put in my password. Apparently there's a way to find the password by just hearing the sound of the keyboard. Anyways, they want the lexicographically largest valid sequence, and for 3 the answer is 3 1 2 3 2. So we've got that 3 1 2 3 2. Now let's say, I'll just log this up. Now let's say I have I have 4, right? N equal to 4. How do I go about finding a solution for 4? Can I use this? Basically 3 1 2 3 2. I have good gaps between these. I have a gap between 2 and I have a gap between 3s also. Oops. I have gap between 2 and I have gap between 3s also. Can I maintain this gap and move things around? For example, between the 3's there's 1 and 2. I can move it around, but if I move 1 and 2, if I move 2, I should move this 2 also. And the gap between 3 should be the same. Let's say I put a 4 in the front, right? And then let's say the distance has to be 0, 1, 2, 3, 4, 5. If it's 0, then the next one has to be at 4. Now, how do I do that, right? One thing I can do is I can just say 4. I can't put the 4 over here, because if I put the 4 over here, let's say 4, 3, 1, 2, 4 on the left of the 3, then it becomes a problem for the 3. These two are okay, 0, 1, 2, 3, 4, 5, 6. Right, these two are okay, but then these two are not okay, and then these two are not okay. So 3, 1, 2, 3, 2. 3, 1, 2, 3, 2. You put a 4 in the front, assuming 4 as the first element can work things. Where can you put the other 4, right? Like now I can't put it in this end because the distance will be too much. So this is 0, 1. The gap between 4 and 4 will be 3. Because if it's like say I and j, 0, 4, 1, 5, 2, 3, 4. So there will be gap is 3, right? So I want 3 gap, 1, 2, 3, and put the 4 here. That will become a problem. Because it will increase the gap between the 2's and the 3's. Can I shouldn't increase the gap between the 3's. If I put a 4 here, the gap will be too little. I'm just wondering if I can actually pull this out and put a 4 here. Anyways, like it's gonna be tricky. Let me see what I wrote down before. So look at this. I was writing it down like 3, 1, 2, 3, 2, 4. This 2 is fine. Now 4, where can I put 4 else? I can't put it here because 3 and 3 is a problem. The thing is, what I did over here is, you can see, I think I changed the 1 to 3. Okay, I changed the 1 to 3, and I think the idea is similar to the previous one what I did, right? I changed like in 212 I changed 1 to 3 and then put a 1 somewhere else, right? So I put the 1 in the front, right? So in 212 I changed the 1 to 3. 1 can be anywhere, I put the 1 in front, right? So that I can increase the gap between the 3's and make it as the gap is 2. Now here, so 4, 3, 1, 2, 3, 2. So what I did was, I think here somehow I was like the gap between these two is correct. 0, 1, 2, 0, 1, 2, 3, 4. This is correct, but the gap between these two is wrong. Now I need to decrease the gap, right? Now I can remove the 1. I can remove the 1 and put it outside. Actually, that's what I did. Okay, I can remove the 1 and put it outside, but then once I remove the 1, the distance between the 4's will decrease. and the distance between the 3's, right? What I can do is I can bring the 3 closer. That's what I did. Interestingly, I've also moved the 2 to the side. I made it as again 2 1 2 thing. Again I brought this 2 1 2 thing, made it 3 and put 3 on this side, and then I put 1. I think there's a small pattern here, I'm not sure. And I tried different stuff over here. I put 4 3 1 3 2 1 4 whatever, and it became like 4 to 4 is fine, but 3 to 3 it's like 4 distance wrong, 2 to 2 is wrong. So as you can see, the distance between say 2 4s is 3, the gap, not the distance. Gap is 3, distance is 4 only. Gap between 2 2s is 1, gap between 2 3s is 2. So as you can see here, I actually tried to make this 2 1 2 as 3 2 and put a 4 here and make the gap between 2 3s is 2, between 2 4s is 3, and then no reason to put a 1 anywhere. You can put a 1 even on this side actually, but then that will become lexicographically smaller version, right? Both are right. 4 2 3 2 4 3 1 is actually right. So 1 minute, let me write it down. So 4 2 3 2 4 3 1. This is wrong because 0 1 2 3 4 5, there is no another 4, so it's a problem. These two are fine, these two are fine. Anyways, you still need, so 4 2 3 2 and then 4 3 1, right? This is a valid answer. 0 1 2 3 4 5 6. So this, the gap is good. This, the gap is good. 1 gap. For this, the gap is 3. 1 can come in the front also, in the forward position, like 1 4 2 3 2 4 3. So that's not a problem. But then lexicographically, if you see, only this is right. Here I can move the 1 because there's no another 1 in the, so there's no constraints for where the 1 should be. It can be here also, and the gaps between the others will remain the same, and 1 will just occur once only. But this is lexicographically larger because when you compare these two of same length, this, it differs at the first place, and this has 4, so this is bigger. Now the thing I thought about is, what if I actually try to look at the fixed length? Let's say the size for n equal to 4 is 7. If I say I have 7 boxes, in this case it was 0 1 2 3 4 5 6, right? 7 boxes basically. If I say 0 1 2 3 4 5, 0 1 2 3 4 5 6, 7th one is this, I say. So n equal to 4, size is 7. Now I can start filling up these by looking at gaps. Let's say I want the gap between 2 4s to be 3, right? And let's assume that if I want a largest lexicographically largest valid sequence, let's assume there is an answer where 4 occurs in the first place, right? Gap 1, gap 2, gap 3. Okay, so 0 4, it's good. So if I put a 4 here, the other 4 has to come here. Now let's say I put the 3 next, right? Like now I know the gap between 4s is basically 3. The gap between 3s is 2. Gap between 2s is 1. And then 1. Now the interesting thing is I've already put 4. Okay, now 3. For 3, you actually need 2 gaps in between, and then the 2 3s, which is basically 2 plus 2, 4 numbers, right? Now, do we have any place over here where there can be a gap of, or there can be a gap of 2, right? For example, this can be a gap of 2. and I can put a 3 over here, 2 gaps. Oh, I can't put a 3 here. So that's tricky, right? If there's 2 gaps, I can put it, there should be 2 gaps only, right? If I put a 3 here, I can't put a 3 here, there should be only 2 gaps. If I put a 3 here, 1, 2, I can put a 3 here, yes. If I put a 3 here, I can put a 3 here. So where all can I put 3's, right? I can't put it here, I can put it here. No, 2 gaps, right? If I put it here, I can't. So this is not a place for 3, and this is not a place for 3. This is a place, but you can't put the other 3 here. You can put it here though. So this is a place for 3, right? Or this is one place for 3, 3, 1, right? If this is a place, 1, 2, you can't put it here. If this is a place, 1, 2, you can put it here. So another place for 3 is this. Okay. Is there any other place for 3 other than this and this with gap 2? I don't think so. So let's start off by looking at one of these, right? Let's say you have this one, right? 4, 1. You have 4 and then question mark, and then question mark, and then 3, and then 4 question mark, and then 3. Now these question marks you need to fill up. So you have 4 done, 3 done, you have 2 and 1 left. For 2's, the gap should be 1, right? Can you put a 2 over here if this is the gap? No, you can't put a 2 here because there's already 4 here. If you put a 2 here, there's no other place where there's a gap 1 and then after which you can put a 2. Can you put a 2 here? Gap 1? No. So this is actually not going to help because now you have a gap of 2. I mean totally how many? 1, 2, 3. There'll be 3 numbers. There's no place where there are like you can just put 3 numbers. You can't just put a 2 here and 2 here. That is like 4 numbers in between. That's like 0, 1, 2, 3, 4, 5, 6, right? So 2 and 5, there is like gap is 3. I mean distance is 3. So yeah. So now can we actually get rid of this as a solution? This will not work. What about this? 4 question mark 3 question mark 4 3 question mark, right? So 0, 1, 2, 3, 4, 5, 6. Now you have right 2 with gap 1. You can put a 2 here and you can put a 2 here. So 4, 2, 3, 2, 4, 3, 1, right? So is this a valid answer? Let's check. I don't know. Before that, I think it's a valid answer, but is it the largest sequence? I don't know. One moment. So they have example 5. There's no example for 4. They have for 5. Interesting. Let's actually check if this answer for 4 makes sense. 0, 1, 2, 3, 4, 5, 6. So 0 and 4, that is 4, distance 4, that is great. 1 and 3, distance is 2, great. 3 and 3, this is 2, 5, so 3, great. And then 1, awesome. Can you find something greater than this where 3 comes, let's say after 4, let's say instead of 2, 3 comes. 4 cannot come, that's wrong. Can 3 come here? Can you work things through? Let's see. Can 3 come here? The distance between the 3's the gap between the 2 3's should be 2. 3 and then you can't put a 3 again or else the gap between 4 is gone. So you can't put a 3 over here, so it won't come up. and you cannot put any other number. 4 1 will still be smaller than this. 4 2 is equal. And if you try 4 2 and try bigger than this, which is 3 then 4, then it's wrong. It can't come here because again, like let's say this dash dash and then you have 4, you can't put the 3 over here, right? Because yeah. And then you can't put a 4 here because these two distance, and then let's say you put a 3 over here. So these two distance you have to maintain. Okay, so I'm guessing this is the right answer for 4 4 2 3 2 4 3 1, right? Let's look at it. I think we've got the answer right. Yeah, 4 2 3 2 4 3 1 4 2 3 2 4 3 1 4 2 3 2 4 3 1, right? Now how do you work it out for 5, right? And what if you don't get an answer when you put 4 in the first place? Let's say in this case we are putting 5 in the first place to get the longest thing, to get the largest sequence, right? Because largest lexicographically largest valid sequence. If 5 comes at the first and we find a solution, we can't find something bigger than that because there is no number bigger than 5. Others will just be 4 3 or whatever. Or if both have 5, both solutions that we have has 5, then we look at the next number and whatnot. So if you think about it, you can actually look at it like this. You can actually create now for 5, n is equal to 5. I think 9 is the size, because 5 minus 1 is 4, 4 to 8, 8 plus 1 9, right? Now I'm gonna actually put 9 boxes over here. So 1 2 3 4 5 6 7 8 9, right? Indexes will be 0 1 2 3 4 5 6 7 8. Let's start with 5, right? 5, the gaps between the two 5s should be 4. Gaps between two 4s should be 3. Gap, okay, distance between the two 4s should be 4, but gap is 3. So you have 6 numbers over here, if you see, right? Like let's say 0, and then you will have 5 over here. So 1 2 3 4, that will be 4 numbers. Same way 0 4 1 2 3 numbers. Between the 3's the thing should be 2. Between the 2's the gap should be 1, right? Now can I fit in these numbers with all these gaps that it needs, right? So 5, it needs 4 gaps. 1 2 3 4. You just put a 5 here. Now can you put a 4 next? That too, can you put it here? Because you want a lexicographically largest valid sequence. 5, if you can actually create a valid sequence starting with 5, that will be really big. And then assuming that the other numbers are also big, like let's say after 5 you get to put 4 and then 3 and then 2 and then 1. So let's see if you can put 4 over here. For putting 4, you actually need 3 gaps between the two 4's. If you put a 4 here, you can't put a 4 here, because after 3 gaps you have a 5 here, and that's not possible, right? So can you put a 4 here then? Now before we go there, what should you then put here? If not 4, can you get the next lexicographically largest thing over here? If you can't put a 4 here and get a valid answer, can you put 3 here? 3 requires 2 spaces between the two 3's. I think you can do that. 3, 2 spaces, 2 gaps, and then 3, right? So we have 3. And then the next biggest thing would be 2, right? 2, but you can't put 1 gap and then put another 2 here. Same thing, you can't put a 2 here and then put, but you can. So here 2, you tried. Can you put 4 here? We'll come back to it. Actually, yeah, let's go back to the biggest number that we have left. 5 is done, 3 is done. 4, let's try to put 4 over here, right? If you try to put 4 over here, you will actually get 1 2 3 gaps, 4. Okay, And then let's try to put so 4 is done. Now 2 and 1. Can you put a 2 here? And then no, if you put a 2 here, so this is not possible. So this is not possible because you are still not able to put 2 and 1, right? I mean, you can put 1 anywhere, but you are not able to put 2. So now we can start again and say 5 3 0 1 2 3 4 5 6 0 1 2 3 4 5 6 7 8, right? So 4 we can't put, but you can put a 3 here, and then you can put a 5 here. You can't put a 4 here. Can I put the next number, which is 2, instead of a 1? Because if I put a 1, if 2 is valid, it's possible to create a solution with 2 here, then yeah. So you can't put 4 here, but if you put 2, it requires 1 space. 2, 1 gap, 2. You can't put a 2 here, there's a 3 already. Can you put a 2 here? 2, 1 gap, 2, no. Can you put a 2 here? Yes, there's exactly 3 things. 1 gap and then the 2 2's. So it's 2, 2. Now where do you put the 4 and where do you put the 1? If you put the 1 here, let's say, you can't put the 2 4's here. If you put the 4 here, that is already wrong. You can't put a 4 here because you have already put a 2. You can put a 4 here. Here if you put 4, it's a problem because 1 2 3 and then you put a 4 and the 2 you can't, right? But here 1 2 3, so you can put a 4 here and then 1. So 5 3 1 4 3 5 2 4 2. This is a valid answer. So here you can see 5 3 1 4 3 5 2 4 2. 5 3 1 4 3 5 2 4 2. Right? Interesting, right? So how did I end up with this answer? Like, there is one more answer, by the way. The answer is 5 2 4 2 3 5 4 3 1, right? So can we see if we can actually find as in a relationship between these two? I mean, of course, other than the conditions that they've given, like, can we arrive one from the other? Like, this is 2 4 2. This one says 2 4 2. It's cyclic. It says 3 5 4 3. This one is like 3 1 4 3 5. And then 1. Okay. Anyways, so you can end up with a different solution. So what I did was I started using the next biggest number as much as possible and started going from there, right? So 5 is the biggest number possible. If this is not possible again, let's say this was not possible, then I would just move the 5 to the next position. I was trying out 5 at 0th position and other numbers accordingly. I fixed 5. Next I will move 5 to say first position and then accordingly do stuff, right? And slowly keep doing and keep eliminating different things and then finally get the answer. So 5 3 1 4 3 5 2 4 2. Let's look at the answer on this, and then I'll probably code this and record the code. So here you can see it says 5 3 1 4 3 5 2 4 2, right? So yeah, I mean, I think the way to go is basically first get the fixed length array, okay, of size L, right, based on the formula that is 1 plus 2 into n minus 1, right? And then start filling with numbers from n to 1. Look at gaps. For n between two n's, the gap is n minus 1, the gap, and the distance is n, of course, n not equal to 1, right? N equal to 2 to 20, right? And then what else? Basically n 2 to 20, in this case. N can be 1 also. You can just see here, but in this case the distance in this one alone we don't consider n equal to 1 because 1 distance is 0, it's just in the same place anyways. And then the next thing is you start filling in, right? You start filling in looking at the gaps, how much gap you have, and is a solution possible. Use the largest number first, largest number to be filled first, to be filled or tried first. Right, and then smaller numbers. Right, and then you keep shifting the bigger numbers if you can't find a solution. Keep shifting big numbers if solution not available. Shift the last or latest number that was filled up in the sequence or added in the sequence. For example, once you add 5 and then you add a 4, it's not working out because 4, 1, 2, 3 gaps, and then you put one more 4, then 5 has a problem. Then you push 4 first and ensure that 4 is put in, and then you put 3. So shift the last or latest number, and once you can't get an answer with just 4 being pushed all the way, then you push 5 next, right? So on and so forth. So yeah, I need to try to codify this. I'll try to do that. That's all I had for this video. I'll see you in the next one. Bye bye.